This video is going to take you through 4 multiple choice questions, all from the practice book, and every single one of them will be without a calculator. So when you're looking at them, take a look at them, pause this if you need to, see what you think the answer is, and then when you play it, you can hear my explanation. And again, try not to reach for your calculator. So the first question was a visual question. You're given the picture that you see right there, and they tell you that you have a function, the domain is the interval from 1 to 7, and you're trying to see which of the 5 statements are true. So you're looking for the true one, and you do want to read these carefully because there are times where we'll ask you which one is false. So you want to make sure you know what you're actually trying to figure out. So I'm going to take you through one at a time with these. The first one, letter A, says the limit as x approaches 3 is 1. So the limit as x approaches 3 would be what's happening as you come this direction and this direction. My limit does exist, however, it's not 3, it's not 1, it actually has a limit of 3 because at both sides it's approaching a height of 3, so that one is false. Letter B says the limit as x approaches 4 is 3. So the limit as x approaches 4 actually doesn't exist because as I come towards 4 this way and as I come towards 4 this way, I get 2 totally different heights. So my limit not only does it not equal 3, it doesn't equal anything. Letter C says the function is continuous at 3. It is not continuous because there is a hole there. It does have a limit, but it does have a hole, so it is not continuous. So that one is false. Letter D says the function is continuous at 5. So if you look at 5, this is the point at 5. There is a sharp point there. However, it is continuous. It's not differentiable, but it is continuous. So that one is true. And then just to double check, letter E. Letter E says the limit as x approaches 6 equals f of 6. The limit as x approaches 6 actually does not exist because from the left you're going towards this open circle up here. As the right you're going towards a closed circle down here. So my limit does not exist. So the only one there that is a true statement is letter D. Second one is an area question. You cannot use a calculator. It is a generic area, which I know sometimes is a little bit more challenging for students because you have this K value. They like to use the letter K or A or B in a lot of these questions. So we have a region in the 4th quadrant enclosed by the x-axis and the curve x squared minus 2kx. All we know about k is that it's bigger than 0. We know the area is 36. We need to figure out the value of k. So there are a couple ways to do this. One option, and it would take a long time, is to take each of your choices from A, B, C, D, and E, plug all those different values in for k, and then find the area and see which one gives you 36. I'm going to show you the faster, more efficient way to do this. First thing I want to do is I want to see when does x squared minus 2kx equal 0, because I want to know when it intersects with the x-axis. I can factor out an x, which gives me x minus 2k. So what that tells me is my intercepts are 0 and 2k. Visually, to give you an idea what this is going to look like, my parabola, I know it opens up. It has an intercept at 0 and somewhere at 2k, and all we know about k is it's positive, so somewhere over here. And what's being asked is that we're finding this area. That's visually what you need to be kind of thinking about to do this problem. So we know for area, we set up the integral of top minus bottom. My boundaries of my integral are going to be 0 to 2k. Top minus bottom is going to be 0 minus my function, the parabola. I can then distribute the 0 sign, or the subtraction sign, and I get negative x squared and positive 2kx. I can integrate that pretty easily. I get negative x cubed over 3 and plus 2kx squared over 2. These 2's will cancel. Put your boundaries in. So we're going from 0 to 2k. So when I put 2k in, I get negative. When I cube 2k, I get 8k cubed over 3. Plus, when I put 2k in and square it, I'm going to get 4k squared times another k that's already here, so 4k cubed. This one's a cubed as well. 4k cubed. When I put 0 in, I'm going to get 0, so I'm not going to worry about that. And they tell us the answer is 36. So we get negative 8k cubed over 3 plus 4k cubed equals 36. One thing you could do is you could multiply everything by 3 to get rid of fractions. So you'd have negative 8k cubed plus 12k cubed equals 108. So we get 4k cubed equals 108. Divide by 4. We get k cubed equals 27, and that means k is 3. And that is your answer. A little faster than if you actually would have just one at a time put those numbers in for k, integrated, found your boundaries, integrated, and then checked to see which one gave you an area of 36. Next one is a minimum value, and the reason I chose this one was to kind of reiterate a conversation we had in class. Whenever you see minimum value or maximum value of, and they never mention the x coordinate, what you have to realize is they are looking for the y value. And this one will definitely trick you if you don't realize that. The x coordinate does end up being one of the choices. First thing we have to do here is take the derivative. So the derivative of e to the x is e to the x, minus the derivative of 2x is 2. We need to see when that equals 0. So we need to see when e to the x equals 2. So taking the natural log of both sides, we get x equals the natural log of 2. Now that's the only critical value we get, so we're assuming that that does create the minimum value. If you weren't sure, if you wanted to do a second derivative test, my second derivative would be e to the x, which when I put natural log of 2 in is positive, so that is indeed a minimum. So if you had a couple values and you wanted to see which one was actually the minimum, which one was the maximum, you could do a quick second derivative test. You could set up intervals. In this case, it's the only one I've got, so I'm pretty hopeful that it is the minimum value. Now you'll notice if all you do is get the natural log of 2 and choose A, you're going to fall into the trap that they're expecting you to fall into. With the minimum value, we need the y coordinate that goes with the x of the minimum. So my answer is going to come from taking my function and putting natural log in for x. So I'll have e to the natural log of 2 and then minus 2 natural log of 2. E to the natural log of 2 gives me just 2. So I get 2 minus 2 natural log of 2. A lot of 2's in this problem. And then when you look at your choices, you can see what they did is they factored a 2 out, giving you letter D. So definitely one that if you're not comfortable with the wording, it's very tempting to say A because it is the x coordinate of the minimum. But whenever it just uses that wording, the minimum or the maximum value, it does want the y that goes with that x coordinate. And then one more. This one is a related rate. We had practiced one the other day. I figured practice a little bit more because they can be a little involved and a little bit different than maybe the latter problem related rate, looking at some of a different scenario, more of a geometric example. So we have a sphere, and the sphere has a volume that is increasing at a particular rate. So this 12, if you want to kind of give it a title, we would call that dv dt because that is how the volume is changing over time. They tell us that when the sphere has a volume of 36 pi, so they're giving us that instant. We want to figure out how fast is the surface area increasing. So the first thing I'm going to do is I'm going to figure out what we know, what that volume tells us. So if the volume is 36 pi, and the nice thing is you'll notice this problem they actually gave you some of the formulas, and they will if the formulas are a little more involved. They give you the volume of 36 pi. And what that tells me, if I put that into my volume formula, it gives me enough information to figure out my radius at that instant, and that's going to be important. I'm going to multiply both sides by the reciprocal, so by 3/4. That will give me 27 equals pi r cubed. Pi's will cancel, so we get a radius of 3. So we know we're looking at the instant when the radius is 3. Now we need to get to actually doing some deriving. So I'm going to put that volume formula back up, and I'm going to take the derivative of that with respect to time. So my derivative would be dv dt equals power out front. We'll cancel with the 3 that's there. 4 pi r squared dr dt. Plug in what I know. I currently know that dv dt is 12. And I know that r that I just figured out over here, the r that I'm looking for is 3. I have this side ending up being 4 times 9, which is 36. So I'm going to divide by 36 pi, which gives me, when I simplify, 1 over 3 pi. That is my dr dt, which is not the end of the problem, but it's kind of an in-between step to get me to the end of the problem. Because what I'm really looking for is how is the surface area increasing. So I'm looking for what I would call ds dt. So my surface area, which is given right here, s equals 4 pi r squared. When I derive that, I get ds dt equals 8 pi r dr dt. We're going to plug in what I know now. I know that my radius is 3. I know dr dt I just found to be 1 over 3 pi. Nice thing is things cancel very well, and we don't have to worry about not being able to use a calculator. The 3's cancel, the pi's cancel, and at the end we get d s dt to be 8, and that is letter A. So it takes you through 4 problems, all without a calculator, but all ones that are maybe a little more abstract, that you have to do a lot more than just do a basic derivative or a basic integral.